Welcome back everybody. I am a teacher from Ilm Online Academy, and in today's video the topic is the rates of reaction. This is basically chapter number 8 of the ongoing series for the chemistry 0620, and in today's video we'll be having a look at the reaction rates. So for the review, let's just begin. So the contents which we discussed today are the factors that affect the rate of reaction and the Culian theory for the reaction rate. So first of all, you should know about the rate of reaction. The name of our chapter, which is today, the rate of reaction is the speed at which the reactants are converted into the products in a chemical reactions. So we have reactants that are present on the left side, and when reactants are converted into the products in a chemical change, that rate or that speed at which our reactants are converted into the products, we call it as the rate of a reaction. Rate mostly refers to the speed at which the reactants are converted into the products in any chemical reaction. So the simplest definition for the rate of reaction will be is the speed at which the reactants are converted into the products in a chemical reaction. This is about the rate of reaction. Next, we will talk about the factors that affect the rate of reaction. There are several factors which affect this, and today we will talk about first about the reactant concentration. So the factors which affect the rate of reactions are, the first one is the effect of reactant concentration. Reactant concentration means how concentrated or how dilute the reactants are. Like if we change the concentration of the reactants, then it will increase or decrease the rate of reaction. Means the concentration of the solution, the concentration of the reactants. High concentration means more particles and there will be more collisions and the reaction rate will be faster, and if the concentration is lower or diluted, then means less particles of the reactants, then less collision, and less collision will lead to the decreased or rate of reaction. This is the first one which we will discuss in the detail. Next, we'll talk about the pressure of the gases by changing the pressure of a gas. So the second will be about the pressure of a gas. What will be the effect on rate of reaction if we change the pressure of gas? Next, third one, we will talk about the surface area of the solids. By changing the surface area of the solids by larger particles or with the powdered form, we will see how the reaction rate happens. And the fourth is about the change in temperature. So the temperature change, will the change in temperature affect the rate of reaction or not? We will discuss that detail in this topic. And the last one is by adding or removing a catalyst into our chemical reaction. By the addition or by the removal of a catalyst in a chemical reaction will indicate the increase in reaction rate or decrease in reaction rate. We'll talk about that. So these are the important factors that affect the rate of reaction, and we will discuss each one in detail in this video. Alright, so before starting into the explanation of these factors, first of all, I think you should know about the Culian theory, because all the factors that affect the rate of reaction can be explained by this Culian theory. So I will give you a brief intro about the Culian theory and then we'll move towards the factors one by one. The Culian theory. All the factors that affect the rate of reaction are affected or they are based upon this Coulomb theory, so you should know about this one. So Coulomb theory tells us that for a reaction to occur, because the particles of the reactants must collide, reactant particles collide with each other, reactants collide with each other, and when they collide with each other they have enough energy, and that enough energy is known as the activation energy, which we discussed in our previous topic in chapter number 7, chemical energetics. The activation energy is the minimum amount of energy that is required to start a chemical reaction. So when a reaction to happen to occur, the particles that are present in the reactants, they collide, and when they collide they have enough energy, and that enough energy is known as the activation energy, and that activation energy is enough to trigger a chemical reaction or to chemical reaction to happen. So if the activation energy is less, then what will happen? Then there will be a no reaction. So it should be higher activation energy to start or to trigger a chemical reaction. Collisions which have enough activation energy and result in the formation of the products, those are known as the successful collisions. So this is about the Coulomb theory. The number of successful collisions depend upon the number of particles that are present there and the frequency. So successful collisions will depend upon the number of particles that are present there, the number of particles that are present in the reactants, and the frequency of the collisions. If there are not much collisions, then activation energy is not produced and reaction will not happen. So the frequency of collisions also included, and the last one is kinetic energy of the particles. Kinetic energy is related to the motion of the particles, so kinetic energy of the particles is also important for the successful collisions to happen, and particles must have sufficient activation energy for the chemical reaction to trigger. So this is about the Coulomb theory, and based upon this Coulomb theory we will talk about all the factors that affect the rate of the reaction one by one. So let's first start with the reactant concentration. So now we'll discuss about the concentration of the reactants, and means the concentration of the solution. The concentration of the solution that is used in the reactants, if it is increased, then what will happen? If the concentration of the solution is increased, then it will be a higher rate of reaction. High concentration means more particles are present there. In case of high concentration, if the reactants are highly concentrated, so that means there are more particles in the reactants, and if there are more particles, then there will be more collisions. That is equal to the more collisions between the reactant particles, because the amount of the reactant particles are more because of high concentration, so more collision will result in the faster rate of reaction. So the rate of reaction will be faster in case of high concentration of the reactants. So this is the key point, that how the rate of reaction increases by increasing the concentration of the reactants. High concentration of the reactants are there, that means there are more particles that are present in the reactants and more collisions will happen. Due to more collisions, there will be a faster or increased rate of reaction. Higher concentration of a substance means that there are more particles, therefore more successful collisions will be there, and that more successful collisions are responsible for the faster rate of reaction. Now I will discuss about the example that show the concentration of the two different reactants that we use in an example. Now in the example we have the acid that is used as a reactant, like we have the this is the experiment A, and this one is the, suppose this one is the experiment B, and in this experiment we are using the acid. Acid in the first experiment is twice as concentrated as compared to the other. So in experiment A, the concentration of the acid is 1 mole per decimeter cube, and the concentration of the acid in experiment B will be just half as compared to the A, 0.5 mole per decimeter cube. That is the concentration of the acid that is used in this experiment. So the volume of the acid will be same, the temperature will be same, and the mass of the reactants must be same in both the experiments. The difference is just in the acid concentration, temperature same, volume of acid same, and the mass of reactants must be same. The mass of for example, if we are using the marble chips, so the mass of marble chips will be same in this reaction. So we are just here to check the concentration of the reactants that we are using. So concentration of the solution is twice as compared to the reaction in experiment B. In the acid, in the concentration of acid in the first or in the experiment A is 1 mole per decimeter cube, and in the B is 0.5 mole per decimeter cube. So when the reaction happens between the acid and the marble chips, what will happen? A gas is produced, and the volume of that gas is measured at the frequent intervals. So after the reaction we can also draw a graph. So the apparatus for recording the production of the gas by using a gas syringe will be like this. So this one, as you can see here, this is the apparatus that is used for recording the production of the gas produced using a gas syringe. So the reaction between the marble chips and the acid happen, and when that reaction happens, we have a gas that is present here in the gas syringe, and the volume of gas is measured through this gas syringe. As you can see here, the volume of the gas will be measured by this one because of the measurement on the gas syringe. We have hydrochloric acid and marble chips are present there. When the reaction between the hydrochloric acid and marble chips happens, a carbon dioxide gas is released and the volume of that gas will be measured. So this is the apparatus that is used for the production of the carbon dioxide gas, and here we will do with the highly concentrated acid and with the dilute acid. In the first experiment we have 1 mole per decimeter cube concentration of the acid, and in the second one we have 0.5 mole per decimeter cube. Now we'll record the results by using the graph, and the graph will show the volume of the carbon dioxide that is collected in this experiment A and also experiment B. So the graph for this reaction will be like this. We have x-axis and y-axis. On the x-axis we have time, how much time will it take to produce that specific amount of gas. So the volume of gas or the volume of carbon dioxide gas, the volume will be checked from the y-axis, and we have the measurement. Here we have 10, 20 seconds, 30, 40, 50 and 6. Now here I also show you how to make a graph between the two different experiments. here the volume will be 10 centimeter cube. The volume is measured in 10 centimeter cube, 20, 30, and here 40. When the reaction happens, the start will be from the 0, because at the start there is no gas, because now just the reaction starts. When the reaction starts, what will happen? The reaction is fastest at the start, so the line or the graph will be moved towards upward like this one. As you can see here, the reaction is fastest at the start because a lot of reactants are there and they react with each other, and when they react with each other, now this is the time for the formation of the products, and our graph will be like this, as you can see here. So this is the reaction of the between the hydrochloric acid and the marble chips to produce the gas, and the volume of gas will be measured through this. Now I will show you with the second one with half the concentration of the acid for the experiment B, and experiment B will be like this. The purple one is for the experiment A, and the blue line will be for the experiment B. This is experiment A, and this one is the experiment B. In the experiment A, we have acid that is 1 mole per decimeter cube concentration, and in the experiment B, we have the acid with just 0.5 mole per decimeter cube of acid. So there is a difference in the concentration of the acids, and you can see here the rate of reaction is faster in A because of concentrated acid that is used, and the rate of reaction for the experiment B is less. The curve for the experiment A is steeper than for the B. This clearly shows that the reaction A using more concentrated acid is faster than the reaction B. The curve for the C starts off twice steeply as for the B. You can see here there is a steepness here, so the curve is more steeper for the experiment A. That means the reaction is twice as fast in the experiment B initially. So doubling the reaction of the acid doubles the rate of reaction. Concentration of the acid is twice concentration, so the concentration is double. When the concentration is double, that means the rate of reaction will be in doubles in case of reaction A. So the total volume of the gas produced is same in both the experiments. Both the reactions produce the same volume of gas, although the experiment A produces it faster, right? So the results show that the rate of reaction increases when the concentration of the reactants in a solution is increased. So now we have stated that the concentration of the acid in mole per decimeter cube, these are the units that we use for the concentration. We have also done in the units of concentration in chapter number 5, chemical calculations. So this apparatus is used to study the rate of the other reactions that also produce a gas. This apparatus is used for that. So the reaction between hydrochloric acid and marble chips that we done today, and the volume of the gas that is measured by using the gas syringe here. So this can be used to check the concentration of the reactants that are present there. So this is all about the first factor. Now we'll move towards the next one. Alright, so we have done with the first factor. Now we'll move towards the next one, which is the pressure of a gas. So this is the second factor, the pressure of a gas. When the pressure of gas is increased, then if we increase the pressure of a certain gas, then it increases the rate of reaction. rate of reaction will be increased. And how it increases, I will tell you. The rate of reaction increases because high pressure, if we apply high pressure to certain type of gas molecules, then it will have more collisions, and when they have more collisions, then the rate of reaction will be faster. So just because of that, we have faster rate of reaction because of more collision. Faster reaction rate because of more collisions. So a high pressure means that there are more gas molecules in a given volume of a gas. Just the pressure is increased, which means that there will be more frequent collision and hence power. High pressure means that there are more gas molecules in a given volume of a gas. Just the pressure is increased, which means that there will be more frequent collision and hence more successful collisions are present there by increasing the pressure of a gas. So this is the briefly I describe you about the pressure of a gas. Next, now I will tell you in detail. So if the as we have shown here now, the concentration effect on the reaction rate in the reactions that involves the gases, and in the reaction that involves the gases, increasing the pressure has a similar effect to increasing concentration in a liquid by increasing the pressure that push the gas particles closer together. Like, for example, if you have a container and this container has the gas particles like this, we have gas particles that are present there in this container, and this is the pressure, as you can see here, that we have applied. When we increase the pressure of this container, then what will happen? Now you can see here the gas particles are much closer to each other. You know that gas particles are always moving or colliding with each other and also with the walls of container. There are frequent collisions that are present between the gas particles and also with the walls of the container. So when we increase the pressure is increased and volume is same in the same volume. So the particles are more closer to each other, and by increasing the pressure, so they collide more and they react more readily, so the rate of reaction is increased. By changing the pressure on the reaction that involves only the solids or liquids does not affect the rate of reaction. One reaction that shows this effect of increasing pressure is the combustion of a fuel in a car engine. This is the example for the pressure of the reacting gases in a car engine. Such reaction explosively generates the energy. That reaction is of hydrocarbons in a petrol or in a gasoline burning with the oxygen in the air as they are compressed by the movement of a piston. So these gases are ignited by the spark plug and the resultant explosion drives the piston down and the movement is transmitted to the wheels. So gas vehicles or exhaust gases are ejected through the exhaust valve. So the effect of pressure on the reaction taking place between the gases is also connected to the Haber process, which we will read in detail in our chapter number 9. Haber process is also related to the pressure of a gas. So we will discuss in detail in chapter number 9 about the Haber process, which is for the production of the ammonia, and also for the contact process that is used for making sulfuric acid. Contact process. So these are the examples of the pressure of the gases. So explosion within the cylinder of the petrol engine as the piston compresses the gases, that increases the rate of reaction. So the effect of concentration or effect of pressure on the gases will increase the rate of reaction. Next we'll talk about the third factor. Now we are done with the pressure of a gas. Now we'll discuss about the third one, which is the surface area of the solids. So now about the surface area. surface area of mostly the solids. If we increase the surface area, by increasing the surface area, the rate of reaction increases. The rate increases, and how the rate increases? Just because of more place available for the reaction to occur faster. Like, for example, in the reaction that involves the solid, only the exposed surface area of the reactants is available for the collisions. For example, if you have a cube like this, the surface area that is available for the reaction will be the sides or surfaces of the solid. When you increase the surface area by grinding or by cutting the solid into the smaller particles, then more frequent particles are exposed and allowing for a greater number of collisions, which means more successful collision. For example, if we divide or if we increase the surface area by grinding or by cutting the solid into the smaller pieces like this one, if we cut them into the smaller pieces, now you have more pieces like this one, and now you can see here, now more surfaces are exposed to the collisions or for the reaction to happen. So breaking a cube into the smaller pieces increases the surface area. There are more exposed surfaces. Just before grinding or before crushing them, now we have just these 4 surfaces that are available for the reaction, but after cutting into the smaller pieces or grinding them, more surfaces are exposed. As you can see here, all these are the surfaces. Now we have more smaller pieces that are available. So finely powdered form or finely divided solid have greater rate of reaction. This is because reactions that involve the solid take place on the surface of a solid at much larger surface area when it is in the powdered form, and when it is in the larger pieces. So we have increased concentration of the solid if the surface area is increased. If the solid is being reacted with a liquid in a solution, the greater surface area and the more solid is exposed to the liquid. We have the example of the surface area for the reaction between the limestone and the marble or marble chips and the dilute hydrochloric acid. Like, we have a reaction of calcium carbonate, which is known as the limestone or the marble chips, and the reaction will be with the hydrochloric acid or dilute hydrochloric acid. When it reacts together, it forms a product which is calcium chloride plus water is produced, plus we have carbon dioxide gas that is released in this reaction. So we can use the same apparatus like which we have done before. So in the first experiment, we'll compare 2 samples of the marble chips, one being the smaller and the other than the other. For example, if we are doing with the 2 different experiments, experiment A and experiment B, all the things are same, but there is just one difference, that is the surface area of the solids which we are using. So we have the experiment A and the experiment B. In each experiment, the sample, the mass of the sample that is used same volume is used, concentration of the hydrochloric acid is same, but there is a difference in the marble chips. In the experiment A, there are more smaller pieces than the other. Small pieces of marble chips, and we have larger pieces of marble chips in the B. So now we will compare the rate of reaction between these 2 reactions. Now we'll draw the graph between these 2 experiments. Now I'm here to draw the graph between these 2 experiments. On the x-axis we have time, and on the y-axis we will check the loss in the mass. So in experiment A, we have smaller marble chips as compared to the B. and in the B we have larger. So the reaction between these two, when they start off with this one, at the start the reaction rate is higher, and because there are more reactants that are present there, a large change in the amount of products in a small time, so the reaction is slowing down as it moves further. So the reaction between in experiment A will be like this. The reaction is slowing down, and after some time, when all the reactants are used up, then the reaction is finished, because now no more products is formed because all the reactants are used up. This is for the experiment A, in which we are using the smaller marble chips. Now we'll draw the graph for the experiment B, in which a larger marble chips are used. So this is for the reaction B, and like this one. So you can see here the difference between the A and the B. There are some important points which I will tell you. The reaction is fastest at the start. Here at the start the reaction is fastest. Why it is fast? Because there are more reactants that are present there, and more reactants will react each other to form the products. This is shown, as you can also see, by the steepness of the curve. The curve A is more steeper than the B. This means that the gas that is produced, carbon dioxide that is produced faster with the sample A. The sample with the smaller chips with the greater surface area reacts faster, and the total volume of the gas released is the same in both the experiments, because both have same concentration of acid, the same volume, the same temperature. All the things are same, just there is a difference in the surface area. So by increasing the surface area, what will happen? The rate of reaction increases, means the reaction will move faster. So the mass of calcium carbonate and the amount of acids are same in both the cases. Both the curve flatten out at the same final point. The sample A reaches the horizontal part of the curve first, because there are much smaller pieces in the sample A. So the results show that the rate of reaction increases. So the rate increases when the surface area of the solid is increased. When the surface area of the solid is increased, then the rate increased. So this is the results that we will talk about this one. Now I will show you the journal chemical reaction. This is the journal chemical reaction between the products, between the reactants, We have the time and the amount of product that is produced, which is on the y-axis. So what will happen when the reaction starts? This is the reaction that happens like this. Suppose this is the curve for the reaction to happen between the reactants, and products are now formed. Now I will show you the chemical reaction that is fastest at the start, and it slows down as the reactants are used up. So now you can see here, at the start the reaction is fastest. At this point the reaction is fast, because at this time we have more reactants are there, so they react faster. A larger change will happen here. Next, if you talk about at this point here, the reaction is slowing down. Why? Because all the reactants are used up and they come to an end, slowing down reaction. And here you can see this one. This is a small change in the amount of product in a large time. Small change in amount of product, and at this point when our curve becomes straight, that shows the reaction has finished. The reaction has finished when our curve becomes straight, and here no more products are produced. No more products are produced when that means now the reaction is stopped, because all the reactants are used up and our line becomes stop. So this is the journal reaction that shows where the reaction is fast done, where it slows down, and where the reaction has finished. And also it shows us this is the point that shows now no more products are produced because the line stops here or the curve stops here. So this is about the surface area of the solid which we are using. Now we'll move towards the next one. We are done with the surface area of the solids, and the next factor which we discussed now is about the temperature change. So now we'll discuss about the temperature change, how it affects the rate of a reaction. So when the temperature is increased, increase in temperature means the rate of reaction is increased, higher rate of reaction. The upper arrow means the rate of reaction is higher. And how it becomes higher? Because increased temperature means that more kinetic energy are there in the particles are heated up, their motions are increased, and when the motion increased, then there is a more kinetic energy between the particles, and when more kinetic energy because of the motion, then more collisions will be there. And when more collisions, the particles collide with each other. So when they collide with each other, then we have faster rate of reaction. Now the reactants are converted more quickly into the product, so we have the more or faster or increasing rate of reaction. So this is how the change in temperature results. Now I will show you the temperature change or effect of temperature by using from the example. So we have a reaction or we can done the experiment between the sodium thiosulfate and hydrochloric acid. Plus 2 hydrochloric acid molecules will react and they form 2 molecules to NaCl, plus we have sulfur, plus we have sulfur dioxide gas, and water is released. So this experiment is here, and we will do this experiment. We have a flask that contains the sodium thiosulfate solution. Suppose this is the flask that contains Na2S2O3, sodium thiosulfate is present there, and this flask is placed on the top of the paper, and the hydrochloric acid is added quickly in this flask. We have a paper like this. We have a paper and this flask is present with the paper, and that paper has a cross mark, that is cross is drawn on the paper. So we have a sodium thiosulfate solution that is present there. Hydrochloric acid is added quickly. Now we will add the hydrochloric acid in this. After when we add the hydrochloric acid, the reaction between the sodium thiosulfate and hydrochloric acid happens. So after the formation of the products, we have the precipitates of sulfur that are produced. You can also see here in the reaction, sulfur is produced. Sulfur is in the solid form, so we have the precipitates that are produced, that is very fine and stay suspended into the liquid. With the time, as more and more sulfur is formed, the liquid becomes cloudier. The liquid becomes cloudier because of the formation of the precipitates in the solution, and those precipitates are the sulfur, and the liquids become more difficult to see through the cross that is drawn on the paper. So the time taken for the cross to disappear is measured by using the stop clock The faster the reaction, the shorter the length of the time during which the cross is visible. And this experiment is carried out several times with the solution pre-warmed to the different temperatures. We can do this experiment with different temperatures, and the solution and the conditions must remain the same, only the temperature is altered. So we can also plot the graph between them, and the graph will show some important points which I will show you. Like if we draw the graph between the sodium thiosulfate and the hydrochloric acid, we have the graph. On the graph x-axis we have temperature on the with the degree Celsius, and time to disappear the cross in seconds. To disappear cross, we will check how much quickly the cross will disappear. That shows the rate of reaction. So the reaction between the hydrochloric acid and the sodium thiosulfate, we have the temperature on the x-axis and the time will be on the y-axis. So the graph will be like this one. This is the graph that shows the time and the temperature between the sodium thiosulfate. There are some important points on the graph that show us the cross disappears more quickly at high temperatures. The shorter the time needed for the cross to disappear, the faster the reaction. The curve is not a straight line, so these results show that the rate of reaction increases with the increase in temperature when the temperature mixture is increased. So to be more precise, the rate of reaction is faster when the time taken for the reaction to finish. So the rate of reaction is equal to 1 by time. You can say like this. A graph of 1 by time against the time temperature would show how the rate increases with the rise in temperature. So this is how the rate of how the temperature affect the rate of reaction. Next we'll talk about the presence of a catalyst in a reaction. So a catalyst is a substance that is used. A catalyst is a substance that is used in a chemical reaction. Catalyst decrease the amount of activation energy. So now we have catalyst. Catalyst decreases the amount of activation energy that is required for the chemical reaction to happen, and which means that there is a higher chance of the successful collisions between them. So a catalyst increases the rate of reaction of a reaction without being used up or changed. And at the last we have the catalyst, just like that when we add them. So the catalyst is not used up, it only increases the rate of reaction. A catalyst decreases the activation energy of the reaction. Activation energy EA decreases when we add the catalyst. By adding or by removing the catalyst, if we add the catalyst, then the reaction speed up. By adding, the reaction speed up because this is the work of the catalyst. The reaction rate increases without the catalyst being used up. By adding the catalyst, it speeds up the rate of a reaction, and by removing it, it will decreases the rate of reaction. By adding the catalyst, it decreases the activation energy that is required, so more successful collisions lead to the faster rate of reaction in this one. So this is how the catalyst increases the rate of a reaction. This is a substance that increases the rate of chemical reaction. The catalyst is chemically unchanged at the end of a reaction. Catalysts have a wider range of reactions, and they are useful because a small amount of catalyst can produce a large change in chemical reactions. So the general features of the catalysts are: we have the examples of the catalyst in our living bodies. These are the enzymes. They are living cells also produce the catalyst. They are protein molecules called the enzymes, and these enzymes have some general features like enzymes are the proteins They are very specific. They are specific for the specific chemical reaction. Enzymes control only one reaction or reaction type. Each enzyme controls only just one reaction or reaction type. They are sensitive to the temperature, means they work on a specific temperature. Temperature sensitive enzymes are inactivated or denatured by the increase in temperature. For example, if the temperature is above 45 degrees Celsius, then the enzyme become denatured due to heat. Enzymes work best at the optimum temperature, which is 37 degrees Celsius. So it becomes denatured at 45 degrees Celsius. They are also sensitive to the pH. They are sensitive to the pH. Most enzymes work best in the neutral conditions around the pH 7. So enzymes are being used increasingly as a catalyst in the industry. We have biological washing powder that uses enzymes to remove the biological stains of sweat, blood, or food. The enzymes in the powders are used that break down the proteins and the fats, because enzymes are temperature sensitive, and these powders are used at a wash temperature of around 30 to 40 degrees Celsius. So this is how the catalyst increases the rate of reaction. So next we'll talk about the last topic, which is the Coulomb theory of the reaction rate and the Coulomb frequency. So the Coulomb theory apply in some situations, and this theory states that a chemical reaction takes place when the particles of the reactants collide with the sufficient energy to initiate a chemical reaction. For example, this Coulomb theory is applied in some situations when the solutions are more concentrated, the speed of reaction is faster. A more concentrated solution means there are more reactants in the particles, and Coulombs will occur more often. So they often more collide, the more chances of the particles to react. That means the rate of chemical reaction will increase. For example, if you have two different reactions that happen, we have two test tubes. We have dilute hydrochloric acid that are present in the first one, and we have concentrated hydrochloric acid in the second tube. The more concentrated the acid solution, the faster the reaction with the reactants that we add in. So when we add the magnesium in this is the magnesium metal. When we add the magnesium metal into the hydrochloric acid with different concentrations, dilute hydrochloric acid and concentrated hydrochloric acid, rate of reaction will increase if the concentration of the reactants is increased. So what will happen here, more hydrogen ions are present there in case of concentrated hydrochloric acid, because magnesium react with the chlorine to form MgCl2, magnesium chloride, and more hydrogen ions are there because of high concentration of the HCl, and more particles are present there. But there are less hydrogen ions in the dilute hydrochloric acid because less particles of acid is present there. So more concentrated acid solution, the faster the reaction with the magnesium. So this is how the Coulomb theory Coulomb theory that a chemical reaction takes place when the particles of the reactants collide with the sufficient energy to initiate a chemical reaction. So we are done with this. Next we'll talk about the activation energy. Activation energy is the minimum amount of energy that is required. Activation energy, and that activation energy is the minimum amount of energy that is represented by the E8 that is required to start a chemical reaction. Each reaction has a different value of activation energy. Every reaction have different activation energy when particles collide. So when particles collide, they must have combined energy greater we have greater activation energy. If they have greater activation energy, then they react. If not, then they will not react. If enough activation energy is not provided, then they will not react and products are not produced. Chemical reaction occur when reactant particles collide with each other. So there are some factors that explain why an increase in temperature increases the rate of reaction. By increases the temperature, if the temperature is increased, then molecules move faster. So this is the summary. Molecules move faster, and when they move faster, they collide more. And when they collide more, frequency of collisions increases. Frequency of collisions increases. When the frequency increases, then the rate of reaction increases. So the rate of reaction increases at high temperatures. This is the first one about the temperature, increase in temperature. So the second factor that explain an increase in temperature will be, the second one will be, at high temperature, the upper arrow shows that temperature is increased. The particles have more kinetic energy because of motion, because of high temperature, and these particles collide more. And when they collide more, then they have minimum amount of energy, will have minimum amount of energy needed to react. At high temperature, more of the collisions produce a chemical reaction, and there will be more successful collisions. So more collision means effective collisions or increased collisions are there. When there are increased collisions, and increased collisions are due to the increase in temperature, then the rate of reaction increases. So this is the most important one for the increased rate that is produced by raising the temperature change. So this is about the activation energy, and we are also done with the activation energy, the factors that affect the rate of reaction, the collision theory that we have done with that also. And next we will talk about the last one, which is the catalyst. We have already read about this earlier. Catalyst increases the rate of reaction by reducing the amount of energy that is needed to break the bonds. So this reduces the activation energy of the reaction and makes sure that more collisions are likely to produce the products. So the rate of reaction is therefore increased by increasing or by adding the catalyst. During the chemical reactions, they need different catalysts, and we have some broader group of catalyst that works by absorbing the molecules in a surface area. This process of absorption brings the molecules reactants closer together, and the process of adsorption is also thought to weaken the bonds in the reactant molecules that makes them more likely to react. So some important examples of the industrial catalyst that work here are the iron in the Haber process. Examples of the catalyst are iron. Finely divided form of iron is used in the Haber process, which we will discuss in the next video in the Haber process. And the next example is vanadium oxide that is used vanadium oxide is the catalyst that is used in the contact process. So the efficiency of the solid catalyst in the Haber and the contact process is improved by increasing the surface area available to interact with the gaseous reactants. So this is all about the factors that affect the rate of reaction. We are also done with the catalyst. Catalysts increase the reaction rate by lowering the activation energy of the reactions. So this is all about today. Hope you understand all this. If you like this video, please like and subscribe our channel, and we will meet in the next video.